Alright, so I'm going to discuss the recitation activity problem for recitation number 3 in Dr. Allen's Chem 1220 class. So for this problem, essentially what this builds up to is the fact that you have a reaction going on where you have sulfuric acid mixing with zinc inside a reaction chamber producing hydrogen gas and zinc sulfate. This is the balanced chemical equation here, and I have a descriptive image shown here where you have sulfuric acid at the bottom of the reaction chamber and basically some gaseous volume at the top, marked 16.0 mils for the liquid phase and for the gas phase 122 milliliters. Alright, so for the first part, your goal, your main objective is to find the chemical formula. It is listed here. And then afterwards, you should try to find, essentially, in part B, what is the partial pressure of the hydrogen gas that you've created in your reaction. So you've been given a mass of zinc as well as essentially a concentration of sulfuric acid along with a volume amount, which you can easily convert to a molar amount of 0.016 moles. For zinc, you simply divide the mass by the formula weight, and you end up getting 0.03135 moles. Now, considering that the chemical formula is all 1-to-1 ratio here, you can easily directly compare the two numbers and see that your sulfuric acid is the limiting reagent. So the amount of moles that you will be consuming is 0.016 moles, which you will convert directly over by a 1-to-1 ratio to 0.016 moles of hydrogen gas. So then to go from there and figure out how much partial pressure the hydrogen gas actually is, assuming that none of the hydrogen gas is soluble, is you look at here using the Piv-Nerd equation, rearrange it such that you solve for pressure, and then put in the following numbers here. We have moles of hydrogen that you figured out, the gas constant, the temperature of 298 Kelvin, and you put the volume of your gaseous phase in your reaction chamber, which is 0.122 liters. And you come out with 3.21 atmospheres as far as how much your pressure of hydrogen, your partial pressure of hydrogen is. Okay, so moving forward to part C, now you're trying to figure out essentially how, in reality, how much of the hydrogen gas is actually dissolved in your reaction chamber in the liquid phase. So to figure this out, you have Henry's law, which is placed here, where your solubility of your gas is equivalent to a constant times the partial pressure of said gas. And what we find here is that given the constant in the problem, 7.8 times 10 to the negative fourth mole liter over atmospheres, when you multiply that times the partial pressure that you found earlier, 3.21 atmospheres, you find that you end up getting this value of 2.5 times 10 to the negative third moles per liter, which is your solubility. So to further figure out essentially the answer to C, which is the number of moles, you're looking for the number of moles of hydrogen gas that was dissolved in solution, you simply multiply the solubility by the actual amount of volume of liquid phase that you have, which is the 0.016 liters. When you multiply this together, you find that the amount that would be dissolved is 4 times 10 to the negative fifth moles of hydrogen. Now, in the last part, it asked you, is it reasonable to ignore the amount of dissolved hydrogen and essentially assume that all the hydrogen had in fact turned to the gaseous phase and did not stay dissolved? Well, if you compare the 4.00 times 10 to the negative fifth moles that are dissolved to the total amount of hydrogen that you have actually created in your reaction, you'll see that you have 1.6 times 10 to the negative 2 moles of hydrogen that's been completely turned, that has been completely reacted with, and you see that only a very, very small fraction has actually been turned to dissolved gases, which means you can readily assume that almost all your product has went into the gaseous phase. That is a proper assumption. Thank you.